very excited to introduce Anton Panashenko and Ben Pence from Twitter, who will be leading a talk titled Auto-Tuning Twitter Hadoop Jobs, or Don't Touch That Analytics Dial. Anton spent the better part of 4 years developing cloud infrastructure for eBay and PayPal, as well as Seagate. Afterwards, he wired together continuous integration and deployment for internal and external cloud infrastructure at Tonami. Before coming to Twitter, Anton helped build the next-gen VisaNet, powering all transactions at Visa on open source technologies and commodity hardware with obscenely high SLA and consistency requirements. For the last year or so, he has worked as a software engineer on Twitter's analytics infrastructure. Ben Pence spent the first part of his career as a security analyst in US intelligence. However, he tired of playing spy and wearing fake mustaches, so he went backpacking abroad for a year to find himself. Ben eventually found himself hiding under a tuk-tuk in Thailand and has spent the last 3 years working as a software engineer, also at Twitter's analytic infrastructure. So, without further ado, please welcome Ben and Anton to the stage.
My name is Benjamin, and this is Anton, and today we're going to be talking about how to tune Hadoop jobs automatically. We're at Twitter, in case that wasn't said on the slides. Oh, and there's pictures of us too. Great. So what are we going to be talking about today? Well, the first thing will be the agenda. We're doing that right now. Second thing will be Twitter analytics. So we want to give an overview of how Twitter analytics work, because without that, it doesn't really make sense why we'd want to apply auto-tuning in the first place. So I think getting a sense of what our infrastructure looks like and what our load is on our analytics pipelines will give you a better idea of why we chose to make the decisions we did. After that, we'll dive into a story time where everyone will sit around in a circle, and we'll talk about the adventure of actually creating a analytics pipeline at Twitter and what that entails, what could go wrong. And then finally, we'll talk about why we went into doing the auto-tuning and what the auto-tuning is and how it works at a high level. And finally, Q&A if anyone has any questions. So Twitter analytics, how do they work? So the ETL into Twitter's analytics data warehouse is pretty similar to other companies. We have microservices running in our data centers, and whenever they receive some event they want to emit into the analytics data warehouse, they make some request to some event queue, and that'll eventually write these events into the data warehouse. And so the way that we partition the events in Twitter in the analytics is by hour, and that makes it easy to run batch jobs on the data. So in this case, on the slide, we are receiving and recording all of the tweets, tweet creation, tweet deletion, all that kind of events. We're writing them by hour into our data warehouse. And so we separate them by hour, 4 to 5 a.m., 5 to 6 a.m., 6 to 7 a.m. So if you want to run an analytics pipeline at Twitter, let's say, for instance, we're trying to calculate how many times someone viewed each hashtag, we might want to grab all the hashtags out of all the tweets that are coming into Twitter, and then also grab all the views of all the tweets, and then count for every hashtag that we extract out of the tweets, how many people viewed that tweet, and then we can get some kind of intelligence. And so we actually, as I mentioned before, we're partitioning this data by hours, so the analytics results will also be partitioned by hour. So we have the top viewed hashtags for the hour of 4 to 5 a.m. And that might require us to run multiple Hadoop jobs. So we actually have not just a simple Hadoop job, but we have an entire analytics pipeline. And we use an open source library that we wrote called Scalding to do that, but that's outside the scope of the talk. So the entire data set is eventually generated by scheduling multiple of these hourly jobs to run and compute the entire data set for the hashtags we want to compute. So this can end up being a lot of Hadoop jobs. So just to give you a sense of what our scale looks like, we run 150,000 Hadoop jobs every day, over 58,000 Hadoop nodes in our clusters, and then we are reading in over an exabyte of data every day. So it's like quite a bit of scale. So if we can make any kind of headway in optimizing the way we run Hadoop jobs, it could have a huge impact on costs and happiness of Twitter employees and et cetera. So it's quite a big thing that we can optimize.
So let's imagine you writing some analytics pipeline and you want to compute something, viewed, hashtag, or something else. And before going to production, you basically need to decide some configuration parameters because without it, it's just will not working and will not run. And basic fundamental parameters for Hadoop job, it's basically how many reducers you want to have and how many mappers you want to have. And these parameters you can guess probably and say some random numbers, and it could be even works for you. But in real life, after these two parameters, you need to decide memory parameters because it's most important resource what's Hadoop job using on our clusters and how we calculate chargeback, how we do scheduling and everything around this. And if you come to memory tuning, then you come up with another bunch of parameters what affect your runtime, what's affect your memory consumption and something like that. And how you see from two simple parameters, you come up with a bunch of parameters, and I can continue and add more and more parameters of what you need to decide upfront before you even run at your job. And in reality, it's only for one job, but our pipelines, our one simple flow, it's usually come up with this kind of graphs. It's real, our customers in Twitter, and each node in this graph, it's actually one MapReduce job. And it's coming even harder to guess any parameters for each individual jobs because you have multiple of them. And sometimes our customers are going even crazy and creating pipelines like this. And on last pipeline, it's 300 jobs running for one partition of data, and our customers doing this. And in this case, it's just impossible to decide anything for human. And let's say we even configure somehow our job, but then you running in production, your job, and something happens. You just page it at 4 a.m., wake up, understand that something happens, usual error for Java application out of memory, and you need to deal with it at 4 a.m. And what you do? Humans usually do, they put maximum memory what they can do, and then hopefully cross the fingers and wait until it's done. And it's reality. People do this all the time. When they wake up at 4 a.m., they don't deal with anything. They just set up maximum memory, give the job, and this job finally ended, finally finish it, and they keep these parameters. And what's worse, that they consume a lot of memory, what is not necessary, occupy this cluster, memory on cluster, and not release it. And then you end up that your cluster is full. You cannot do anything. You cannot do any another analytics pipeline just because your cluster is full. And what's next decision is buy new hardware. But how you saw before, we already have 58,000 hardware. And buying more and more hardware, it's like a bad way to do because you end up like a lot of hardware and do nothing. And for us, in Twitter, we decided that we need to invest and somehow take care of all these parameters, take care of memory optimization and right configurations for memory. And then we come up with auto-tuning.
As Anton said, it's really difficult for one single person to figure out all of the parameters to set for all of the jobs that they might be running. And a lot of teams at Twitter will own, I don't know, 10, 20 jobs that are each running 15, 20 Hadoop jobs every hour. So that can add up to like quite a bit of complexity in terms of just like people problems. So what we came up with is this service called auto-tuning. And the way auto-tuning works is when you're about to run your Hadoop job, you ask the service, hey, what should I use to actually run my Hadoop job? So we were talking about, for example, the number of mappers, the number of reducers, how much memory to give each one, stuff like that. So we'll talk about just in a second how the estimation actually works, but the auto-tuning service will estimate for you some parameters that things will work well for your job. So then what you do when you receive those parameters from the service is you go and run your job. And to make the process be a feedback loop, we take the run metrics, the Hadoop counters that we get from running the Hadoop job, and write them back to the auto-tuning service. So the next time that we come and want to run the same job again for, let's say, the next hour of data we want to compute, the estimator, the auto-tuning service, can make a better estimation of the parameters. So this is generally the high-level diagram of like how auto-tuning works. So that was the first iteration of auto-tuning. The second iteration was we talked with customers and we found that people don't have a good sense of mental models in Hadoop. How does Hadoop work? How do some of the runtime parameters we can pass affect the performance of Hadoop? So they really don't know what to ask from the auto-tuning service. So we came up with this idea of just using the SLA for their analytics pipeline. The SLA in this case is what's the maximum amount of time I want this analytics pipeline to run for? Because they might have people who depend on their analytics pipelines that depend on their analytics pipeline downstream, or they might have services that are querying for the data that they're providing in their analytics jobs, pipelines. So in this case, for example, we've said we want our analytics pipeline to take no longer than 45 minutes. So that's something that we've asked from the user. That's the only thing we've asked from the user. And then we use that information to give them an approximation of Hadoop parameters we think should work to get them there. So the way we do that is right now we're targeting mapper and reducer counts. And the way we tell them what to schedule, what to use for those parameters, is we look at the typical amount of time that it spends processing data. Because after all, Hadoop MapReduce is basically just a big framework for like copying data from one format to another. So we look at generally how much time in the past has it taken for the map phase for this particular job to run per megabyte. And then we look at how much input data do we have coming in. And so we use that to make a prediction on how long we expect the current phase to take when we run it now. And then we compare this. So we have the how long we expect it to take, how long we want it to take, and then we compare these to figure out what multiplier we want on the mappers, whether up or down, to accommodate the new SLA. On the reducer side, since we don't know how much data the mapper will actually write out, we have to guess. And so the way we guess that is we look at how much input we're getting, and then we also look at historically what has been the ratio between input coming into the mappers and input coming out of the mappers. And so that's how we kind of figure out what the input is going to be for the reducers. And then just like in the map phase, we look at what is the typical amount of time reducers for our job have spent processing data in the past, so per megabyte. And so we multiply these together, also again to get a estimated reduce phase time, and then we compare it again to what is the amount of time we want it to last for, and we use that comparison to decide how to scale the reducers up or down. So this is the SLA-based estimation that we do.
And actually, with this SLA parameter, we can adjust and we can understand everything else. Because what is matters, it's only matters for users, it's what is runtime will be. And in end of days, they don't care about anything else, and we can understand, do we need to give them more memory? Will it affect their runtime? Do we need to tune some other parameters like slow start or spill factor, what happens on map side and something like that. And everything coming from this. What we want to do in next couple of months, couple of quarters, we want to open source this service to take advantage of open source community and we already spoke with some companies like LinkedIn. They're very interesting with this because they already investing a lot of money in Hadoop ecosystem, and they have another project like Dr. Elephant, what's help you understand what is runtime of your job, what is good metrics, what is not good with your job, but they cannot automatically do some adjustment for runtime based on this information. And our service can do this. Also, we want to understand, we want to derive information about cluster at current time, because if your cluster is busy and full, it doesn't make sense to schedule your job at all, because you don't have resources to schedule your MapReduce task, and maybe it's better to wait a little bit, 15 minutes or something like that, and schedule later. Also, we working in Twitter. Our pipelines works based on scalding framework, and we work on new features to derive more information about user computation and understand what they really do, and understand what how they process their data, because we found out in our history that many users really taking same data sets, apply same intermediate processing, and do only difference in end of these jobs. This means we possibly can inject and rewrite the plan and reuse this intermediate data and save our computation. Don't compute same thing twice. And also, we started adopting Spark and Twitter. And that means we more and more run Spark jobs in production. And our customers for Spark meet same problems. They need to also configure Spark jobs. You need to understand how many memory you need, what is parallelization for Spark job, and everything same applies to Spark jobs. And we want to extend this service to understand some specific things what is applies only for Spark. And probably we end. And you can ask us questions.
Have you looked at Tez as an execution engine that you might support?
We doesn't have Tez in Twitter. We try to test, but in some reasons we're not going with Tez. We want to support, but in real life it's not our priority, because we don't have this problem at all. And it's why we want to open source to support more and get something from community.
Because all this information, right, mapper information is already stored in the application timelet server, so it will be very easy for you.
Yeah,
to do it.
It's not a big deal, because everything what's running on Hadoop, it's basically same things. From our perspective, it's just processing of some bytes and transforming to another form of bytes. And some functions, some pure functions applied to these bytes. And in this perspective, we of course can integrate easily with Tez. It's just a question of where to inject these overrides, because we right now take advantage of scalding and inject our parameters and our service call in scalding and cascading itself. And this, to support Tez, we need to understand what's Tez ecosystem, how people write their Tez pipelines, something like that. Probably we will work on, we will add in future support of Tez in scalding, and then it will be automatically get support of Tez from auto-tuning. But it's not like, I don't have ATA on this.
Okay. Thank you.
You can work on scalding, by the way, and because it's already open source, and it will.
So that is one of the things that's missing in Dr. Elephant, actually. So it does not have Tez support. So we were evaluating that, so just asked.
We had a you can try to evaluate Dr. Scalding. It is a Stripe project. Maybe it has a support, I'm not sure. I think, I don't remember that they have, but they very, very similar to Dr. Elephant.
Timberlake.
Timberlake, yeah, they call Timberlake. It's Stripe project.
Just a quick question. I think you covered it in the beginning, but I might have missed it. Is you have a fixed cluster size, though? Is that correct? And it's pretty massive. I mean, so this is.
We don't have it. I'm not
We
sure.
own our own cluster, right?
Yeah,
I think that's the question.
we have our own clusters in our data centers. We have multiple data centers. It's 58,000, of course, not one cluster. We have around 6 clusters, independent clusters in different data centers. But yeah, overall it's 58,000, and it's our own Hadoop infrastructure.
Just a little tiny footprint.
Yeah, little bit. Yeah.
For your auto-tuning equation or the logic behind it, is it also capturing the actual, whatever that failure or success of the job was, and like how long it took to run? And
Yes, we capture whole information about your jobs and your pipeline, and we even can show you recommendation about what you can improve in your jobs, because multiple times we can understand that for this particular processing, it can be, for instance, done by map site aggregation, something like that, and it's huge advantage to map reduce jobs. It will be save a lot of money or a lot of processing time, kind of this information. We're not yet ready to show off fancy web UI to our users, but it's also some point of on our roadmap to give them more visible way to consume this information and deal with it. Because sometimes to users, for them, it's very interesting to understand, compare to different runs, and understand what's performance metrics is different for different runs. If we tune some parameters, how it affects overall performance of their flow or something like that. Or in other cases, they can change their flow a little bit, tune something in code, and they want to compare what it is doing better or not. And we have all this information. We can understand that this code was, these two different codes actually same logic to processing same data. And we can understand that it's same and apply for them some optimization. Thank you.
all right.
Thanks.
Thank you.
By the way, we are hiring, and if you want to work on this project and doing open source, come to Twitter. We need at least 3 people, and we have a lot of things to do in this year, because we refactoring whole ecosystem in Twitter for processing data. It's not only batch processing; it's a real-time processing, Spark, Heron, Kafka streams, and everything fancy what you really like to do. We have a lot of offices. We have offices in Boulder, Seattle, San Francisco, Boston, New York. We can hire you everywhere. We have offices in London, Paris. If you want, come.